This is just to open your mind. The world is not like they told you. There are so many anomalies in eclipses. You can study the shadow using real-life scale model. I've tried with Pupung. We're using real sunlight, no question about brightness, lumens, and so on. But don't do it in open air, cause the bigger the light, the smaller the shadow. In total solar eclipses, the source of light should be the same with the object that eclipses it. Using scale model, for a 10 centimeters Earth, you have to use a 2.92 meters of pipe. This is very important to make the source of light to scale. The result is quite devastating. The shadow is about 16 times bigger than it should be. In reality, eclipse shadow size is about 70 miles or around 100 kilometers. They make it in CGI cartoons as if a 3,474 kilometers of moon from 384,000 kilometers distance can make a 100 kilometers of shadow. So they make CGI cartoons with shadow shaped like a pencil. It doesn't exist in reality. With real-life scale model, the shadow is actually 1,000 miles or 1,600 kilometers. With the globe model, eclipse shadow would cover the whole Kalimantan island. Unbelievable! With the globe model to scale, eclipse shadow would be so big that can cover Portugal, Spain, and France at once. This is a disaster for the globe model. All your life, you only see eclipses of fantasy. On the other hand, in the flat Earth model, the diameters of the sun, the moon, or whatever object eclipsing the sun is about 32 miles or around 60 kilometers. If you don't like mathematics, you can use AutoCAD, a neutral software for professionals. You can verify by yourself from 5,000 kilometer height. They will make shadow size exactly like reality. 105.7 kilometers, like the real eclipse shadow in Idaho Falls. Many people argue whether the globe model can make eclipse shadow from west to east or not. Let's make it clear once and for all. If we put all the data on the table transparently, in a way that everyone can understand, measure, and verify themselves, the answer is yes and no. Yes if and but no. Now the yes if first. Yes, eclipse shadow on the globe model can move from west to east only if Moon's orbital speed is faster than Earth's rotation speed. In heliocentric model, the Moon's orbital speed is twice as fast as the Earth's rotation speed. With this paradigm, for sure, the shadow will move from west to east. Let's make a model to make it easier to understand. The distance is not to scale. The moon should be 30 Earth diameter away. If the Earth rotates 1,670 kilometers in 1 hour to your right, and the moon orbits 3,683 kilometers to your right too, then you draw a straight line from moon's diameter to the Earth. You will see the moon's line is farther than the Earth's line. But of course, 3,683 kilometers is farther than 1,670 kilometers. You don't even need a model to understand. This is called linear speed. In this way, the eclipse shadow moves from west to east because the moon is faster than the Earth. It's mathematically correct based on that assumptions and paradigm. But there's a big problem. It defies natural fact. If the moon is faster than the Earth's rotation, you would see the moon is setting to the east, the opposite of reality. Let's use mooncalc.org to make it easier. Find a place that has 90-degree elevation of the moon. Imagine the Earth is moving 1,670 kilometers per hour west to east to your right, and the moon is moving 3,683 kilometers per hour to the same direction. Within 1 hour, you would see the moon is more to your right because it's faster and travels more distance than the Earth, right? Wrong. See what happens if you add time for 1 hour. Ooh, the moon is going to your left because the Earth is rotating faster. How come 1,670 kilometers per hour travels faster than 3,683 kilometers per hour? It's because the distance traveled by the moon is 60 times longer than Earth's circumference. Now we're talking about the other kind of speed, the angular speed. Take bicycle wheel as an example of angular speed. The farthest part from the axis, the tire is moving faster than the axis, but actually it's the same angular speed. The farther from the axis, the faster it moves, but actually the same angular speed. Now, the Earth is rotating 360 degrees in 24 hours. It means 15 degrees per hour. If the Earth is moving 15 degrees counterclockwise to your right, and according to heliocentrism, the Sun is at rest, then you will see the Sun appears to be setting 15 degrees to your left. That's the angular speed of the Sun due to Earth's rotation, okay? While the Moon is orbiting the Earth 360 degrees in 29.5 days. Some people like to say 27.3 days, sidereal month, the Moon's position with respect to the stars. It's irrelevant, for we are counting the Moon's position with respect to the Earth, nothing to do with the stars. So we have to use synodic month, average 29.5 days. The angular speed of Moon's orbit is 1 per 24 hours divided by 29.5 days times 360 degrees equals to 0.51 degree per hour. That means when the Earth in an hour is rotating 15 degrees to your right, making the Sun appears to be setting to your left 15 degrees, the Moon is moving 0.51 degree to your right. That makes the Moon appears to be slower than the Earth's rotation. Let's go back to mooncalc.org. The Moon's elevation angle is 90 degrees. Then change the time to 1 hour later. Now you see the elevation is subtracted to 75.81 degree. 75 degree because the Earth is rotating 15 degree from previous 90 degree elevation. 0.81 degree is the Moon's traveling distance in 1 hour. Mooncalc is using different moon distance on that day, or perhaps they're using sidereal month. It's all mathematical assumptions. They don't even look to the sky. The Moon moves 0.5 degree against the Earth moves 15 degrees per hour. With these assumptions and paradigm, for sure, the eclipse shadow moves from east to west, the opposite of reality. So which one applies to the Moon and the Earth's speeds that creates eclipse shadow? Linear speed or angular speed? They will say it's the linear speed that matters.
The Moon is orbiting about twice as fast as the Earth is spinning. So if we're looking down on the Earth and we're at the Moon, we see the Earth spinning, but the Moon is moving faster.
Wrong. Even if you're at the Moon, in 1 hour, you would see the Earth is setting 0.51 degree to your left, while it's rotating 15 degrees to your right. Even if you're looking from the Moon, the Earth's rotation is still faster. That means eclipse shadow in the globe model goes from east to west, the opposite of reality. Official data taken from NASA's website, the Great American Eclipse Path. NASA also provides extra link for more details. This is a picture that destroys globe model if you understand what it means. First, let's find out the eclipse duration that began at the far west and ended at the far east. We're not looking for eclipse beginning and ending in one location, as there are so many locations. What we're looking is the beginning and ending of the whole eclipse happened on that day. You just click the path and they give you complete information. See the start of partial eclipse, it's 1555 UTC. Then the end of partial eclipse, 2055 UTC. Now we have credible data that total eclipse duration is 5 hours. Secondly, how far is that eclipse length? Take a look at the longitude. It started at 171.2 degree west and ended at 27.4 degree west. The eclipse length longitude is 143.7 degrees. Do you realize how far is 143.7 degrees in the globe? Let's copy-paste some coordinates from the eclipse site to Google Maps to measure the approximate distance. It's around 40,000 kilometers. Now, apply it to the globe map. See, the eclipse distance, 143.7 degrees, is already 40% of the Earth's circumference. So, within 5 hours of eclipse, out of 24 hours a day, or around 20% of the day, somehow, miraculously, the shadow length covers 40% of the globe. Let's make a scale model now to understand that the eclipse length of 143.7 degrees is mathematically and geometrically impossible. We've made scale model of the eclipse using AutoCAD. In this video, I'm collaborating with many people from Flat Earth 101 community. You have seen the work of Najwa and Anggoraji specially made for you. For this AutoCAD, I want to make it as precise as possible, so I collaborate with people from the community again, this time with Tejo. He's a successful architect who is very familiar with AutoCAD. And he's not alone. People in his office also help us to make this model. They are flat earthers too. These are the assumptions I took from mainstream science database. We made this model based on that official data at that particular date and that particular spot as referred by NASA. Let's start with the Earth. Of course we can make it pretty with 3D Earth, but that's not our objective now. It's not about beauty, it's about precision. The Earth radius and diameter are precise according to heliocentric data. These 5 lines represent the Earth's rotation for 5 hours, the eclipse duration. Each line represents 15 degrees. 5 lines equal to 75 degrees. The 0 point represents the first second of the eclipse. The Earth rotates anti-clockwise from west to east. So if you are standing over here at 0 point, in 5 hours you will be over there. Now let's go to the Moon. It's 30 Earth diameters away. The Earth is a small circle over here, and the Moon is over there. Let's zoom it. This is the Moon at 0 point when the first second of partial eclipse started. These 5 moons represent its movements every hour, 1, 2, 3, 4, 5 hours. This is the Moon's radius and diameter according to standard heliocentric. This is the Moon's traveling distance every hour. Within 5 hours, it travels 18,415 kilometers. That's the linear speed. But the orbit is so big, 29.5 days, and 5 hours means almost nothing. So if you draw a line from the Moon's axis to the Earth's axis, this 18,415 kilometers is only 2.55 degrees angular speed on Earth. It's hard to see at its true scale. Let's split it into 2 screens, the Moon on your left side, the Earth on your right side. This is the 0 point when the first partial eclipse happened. The line goes to 0 point on Earth. In 5 hours, the Moon will be over there. If you're standing on Earth over here, 5 hours later, you will rotate from west to east and you'll be over here. You will see the Moon is setting to the west due to Earth's rotation. Exactly like you've seen at mooncalf, you add time, the Moon goes to the west. And the elevation angle is subtracted from 90 degree to around 75 degree in 1 hour. For 5 hours, it would be around 18 degrees near the horizon, almost setting. This is the proof that it's the angular speed that applies. What about the linear speed? After 5 hours, the moon's position is over here. We draw straight linear lines from the moon. Where do the lines fall on Earth? Man, it's far outside the Earth. Theoretically, linear speed is wrong. After 5 hours, you would see the moon is setting to the west. In reality, you don't see the moon is over here like it's setting to your east. The moon is over there, near the horizon, setting in the west. The funny thing is, even though the moon is over here setting in the east, the shadow will fall outside the Earth. If you use angular speed, eclipse shadow moves from east to west, the opposite of reality. If you're using linear speed, the moon sets in the east, and the shadow falls outside the Earth after a few hours. Any which way, they're wrong. It really doesn't work on the globe model. What about the shadow speed? We've been through this. Their own science says the eclipse shadow speed is the same as the moon speed itself. Look once again at their eclipse shadow speed. The shadow is never faster than the moon speed.
The shadow knows.
Poor globe model. Let's be generous to them. Give the globe model a generous discount. Let's start not from 90-degree elevation, but instead from 0 degree like we have solar eclipse at 6 a.m. in the morning. You can't even see the sun at horizon level. Then you have 5 hours eclipse. And still, if using linear speed, the shadow goes outside the Earth. Do you know why it fails? Because you can't get 5 hours eclipse on the globe model. The moon would travel 18,415 kilometers, while the Earth's diameter is only 12,742 kilometers. That would make the moon half Earth outside the Earth. This is real fantasy, folks. Congratulations. Based on their official data, you just found a fatal error on the globe model. Now let's see the eclipse movement with 3D model. You can use solar system scope. It's supposed to be correct according to heliocentric model. The time, speeds, directions, and eclipse duration are to scale. Only the sizes are not to scale. They make them bigger to make it easier for you to see the movements. Set your time to August 21st, 2017 at 3:55 p.m. UTC. We'll run it for 5 hours, scaled to about 5 seconds. It's gonna be quick, but we can replay it. The time will be 3:55 p.m. to 8:55 p.m. Please focus on the Earth's rotation speed and direction, also the moon's orbital speed and direction. See which one is faster. Ready? Go! You see that the Earth's rotation is faster. Let's zoom in. The moon is almost like not moving. That means they're using angular speed. The Earth's rotating at 15 degrees per hour. The moon's traveling at 0.51 degrees per hour. With this angular speed, to which direction the shadow goes? Because the Earth is spinning faster to the east, the moon's shadow goes the opposite direction, from east to west. Exactly like Najwa has shown you, only this 3D animation is using true scale of speeds according to heliocentrism. But don't trust CGI cartoons. Let's make a real-life model now. This time, I collaborate with Pupu. He's a technical engineer and a very diligent researcher. He made our previous AutoCAD scale model into real-life model. This is the Earth and the Moon's model to scale. This is the Moon's traveling distance in 5 hours. And this is the Earth's rotation in 5 hours too. This is the Earth-Moon distance. You remember those angular lines. The Moon travels 18,415 kilometers, but is only 2.55 degrees from the Earth's axis. That's the true sizes, distances, and speeds according to heliocentric model. Assisted by Dama as cameraman, we put 3 cameras on the model. First one is above the Earth to see the Earth's rotation angles. Second camera is above the Moon to see the Moon's traveling distance and angles. Third one is behind the Moon to see where the shadow falls in 5 hours time scale. Remember, we're not looking for the eclipse shadow size. The source of light with the scale should be 475 meters or almost half kilometers away. And the lamp diameter should be 4.36 meters. It's irrelevant for this purpose because we're just looking at the shadow's direction, not the shadow size. We start from the 0 point where the eclipse starts. You see the Earth is at 0 degree position and the Moon is also at 0 degree position. The shadow is slightly to the west of the Earth because the eclipse started at 15:55 UTC or 10:55 local time in the morning. If you stand on that shadow point on Earth, you would see the Moon is slightly to the east where the Moon rises as appears on Earth. Now the Earth rotates for 15 degrees. The Moon is moving 3,683 kilometers, but only 0.51 degree from the Earth's axis. See where the shadow falls. Oops, it's not angular speed, but linear speed. This is a disaster for the globe model. Yes, it means the shadow moves from west to east, but it means the Moon is setting to the east, and within 3 hours, the shadow will go outside the Earth. Second hour. Third hour. You see the shadow already falls outside the Earth. Fourth hour. It's more than the Earth diameter. This is the fifth hour. The shadow goes half Earth outside the Earth. How can heliocentrism predict eclipses if the maths don't even add up for one eclipse? No wonder NASA still uses ancient Babylonian solar cycle.